Hello, welcome back to another episode in the PWA series. So, in the last episode, we looked at how to implement static caching so as to make certain static resources available offline. However, we ran into the issue of some missing styles, which didn't lead to the desired look and feel for our app and offline. So we'll be fixing that in this episode through dynamic caching, and also we'll look at cache versioning, where we'll manage different resources in the cache to ensure that only the latest version of a given resource, say like a CSS styling or JavaScript file, is available to the app through the cache. So let's quickly go to the Chrome browser and look at what we're trying to address in this episode. So we're on the Chrome browser. We're offline right now. Go to the application tab, service workers section. We are offline. So we are missing some icons here. That is because of the missing starting through CSS. If you go to the network tab, so here we see that there is one resource that couldn't be fetched since we're offline. So if you just click on it, it is actually a .woff2 extension file, which is a font file. The request for this resource is actually originating from this URL, material icons. So if you go in here and go to the preview, so you see the source attribute here. So through this attribute, it's requesting the font file that is missing here. So you can see that it's identical. The same .woff2 format. That is because we're not storing it in the static cache here, and also there is no way for us to know because it is being made as an intermediate request by the actual material icons request that we have here. So the way to fix this would be to intercept the fetch requests that are being made whenever there is a cache miss, and to store the responses, those requests as well, in a different cache, so that it would be available offline just like the static assets. So that way, depending on whether or not the user has visited a certain page, we would have access to both the static and the dynamic assets, and can lead to a better user experience with more wholesome web pages. So if you go back to service workers and get the app online and refresh it, so this is pretty much the look we want even when offline. So let's go back to Visual Studio Code to work on implementing the dynamic caching. So we are in the Visual Studio Code again in serviceworker.js. So we actually have pretty much most of the code needed for dynamic caching. So the only thing that is missing is capturing the response of these fetch requests, which are made when there is a cache miss, because we first look at the cache, and only if there is no matching response, then we make the fetch call to the network. So we'll have to capture the responses of these fetch calls and then store them in a different cache. So since the fetch returns a promise with the response, we can capture it through a then method. And then we get access to the response there. So since we already have a variable named response here, we can just call it res. You can call it anything else. And in here, first we need to create a cache. Let's call it dynamic assets, just like we created the static cache. And because this also returns a promise, which with the instance of a new cache, and I can use the then here to get access to that cache reference. And now we add an entry with the capture response in the dynamic cache. So we'll use the put method here from the cache API instead of the add or add all, because we've already made the request and also captured the specific response. So we can just add the request response pair through the put method. So if we quickly go back to the documentation, so talking about the put method here. So here, as you can see, we need the request and the response as input. So back to the VS Code, caches dot, it should be cache, which is the instance of the dynamic cache, dot put, and the request, even dot request, and the response. So one thing about the response here is you can only use the response object once. So because we want to store this specific response in the cache, we have to clone it or make a copy of it so that it could be stored in the cache and also returned as the actual response of the fetch call here. So we use the clone, which makes a copy, stores it in the cache, and then we can return the original response that is expected of this fetch call here. So that is pretty much what you need additionally to incorporate the dynamic caching, because the fetch here, it to be able to intercept any intermediate requests or requests made by other pages apart from the landing page. And because we first try to match the caches here, so the caches.match actually looks at all the available caches and looks for the first hit matching the given event.request. So let's go to the Google Chrome and see if this works. So back on the Chrome, so we're online, and since we actually made a change to the service worker, so when we refresh it, we would have to reactivate the new version of the service worker. So you can skip the waiting. So it's now active. You can see it in the log and refresh it again. So you see we have the app fully rendered here, and you can see we have a new cache here apart from the static assets. So if we click on the dynamic assets, so we have all the URLs outside the static assets cached in here. So if you remember, we previously saw that we had that actual font file that we couldn't capture or cache. So that is captured now in the dynamic cache. So when we go offline, we should be able to access the required styling to properly render the landing page here. So let's go to the service workers, get it offline, now refresh it. You now see we're able to render everything perfectly even when offline. That is because we now have the missing assets from the static cache captured in the dynamic cache here. So if we go to the network tab, you see all the requests are being rendered correctly without any misses from the service worker. So this is how you can render more complete web pages through static and dynamic caching. So we're on the landing page here. If we go to the favorites page, which is a different page, we haven't visited it when we were online. So when we go to the favorites here, it should render that offline page. And you can see even here, we're able to correctly render the icons because these are shared resources across pages. However, we still see that in the network tab, we have some font that is missing, and also the favorites URL is also missing. So now if we go online to the service workers and we visit this page, let's refresh it again. So we have now visited the favorites page, and if we go to the dynamic cache here, so you see we have additional resources that have been cached specific to the favorites page here. So we have the default URL for favorites. Also notice that you have two different URLs cached as separate requests, one without the forward slash and one with the forward slash. So this is an important thing to note, because these are not just strings, and even a single forward slash can register it as a different request. So since the required assets for favorites page have also been cached, now let's test it out by again going offline and trying to refresh it. You see we still have the same page rendering the same set of resources even when offline. So go to home page now, have the same page rendered without any issues. So I hope that gives you an idea of how we can use the combination of static and dynamic assets stored in caches to give that offline experience and also speed. So now that we have a mechanism to store resources or assets that change over time, let's display the products as well, which we have commented out in the app.js. So let's go to Visual Studio Code and in app.js. So right now we have the data stored in memory in the map data structure. We will in the future episodes add on a backend so that the data is stored on a remote server. But for now, we're just working with in-memory data structures. So let's uncomment these lines of code to add the data. Now let's save it, go back to Chrome browser and refresh it. So even when we refresh it, you're not able to see the data being listed on the web page. Now, why do you think that is? So if we actually go to the static assets, we do have the app.js being cached here. And if we go to the service worker quickly to see how we're rendering the response in the fetch request. So we first check the caches, and if there is a match, we rendered that response. So we're able to find a hit for that request app.js, and we're serving it from the static cache here. So if we check the resource, let me maximize it a little bit. So if you see here, we see the version of the app.js that is being served from the cache doesn't have the data uncommented here. So it is all still commented. Same with the favorites here. So now there is a mismatch in terms of the latest version of app.js file. That is because the cache resources are refreshed only when there is a change in the service worker. So any changes done in the actual app files, like in the source folder here, have to be coupled with some change in the service worker. So that's where this cache versioning comes into play. So what we need is some mechanism that could track the versions of different caches, which in turn reflect the changes in the actual resources. So that way, each time there is a change in the normal files, there has to be change in the service worker too. And that way the caches can get refreshed to store the latest version of all the files. So let's go back to the service worker and work on the cache versioning part. So right now we have hard-coded the cache names here. So for the static one, we have the static assets. And for the dynamic one, we have the dynamic assets. So for better code maintainability and also readability, let's try to put them in some variables so that we could make the change in one place and that will be reflected in other parts of the code. So this is a common practice or a best practice. So let's store it in an object. Cache name, so let's call it cache list. So we have two entries here, one is static, one is dynamic. Since this is a JavaScript object, the key doesn't have to be a string, but the value will be a string. So it will be static assets here. So we just cut and paste it here and replace the name here with the cache list dot static name, or let's call it static cache. That's much better. We do the same with the dynamic cache as well. So it is the dynamic assets, cut that, cache list, and dynamic cache. So this way you don't have to update the code in two different places, and you can just make the change at the top here, and that just makes your life easy. So what we want is versioning. So what we'll do is each time there's a change in some file or the resource, depending on whether it's a static or a dynamic resource, we update the cache name with the appropriate version. That way you will have a cache with old resource and a cache with a new resource, which can help with differentiation. So we need a way to track the version as well. So let's have a different JavaScript object for that. Let's call it cache version. So we'll have two different versions for static and dynamic. Let's start with one for both. So in the cache list here, we will have to add the cache version as well, like the current cache version in the file, so that we have a way to know the latest version of the cache. So we'll update this to back quotes because we'll have to do some string interpolation here. So we'll just append the version to the end. That's static. And we do the same for the dynamic cache as well. So change it to back quotes. So this is the simple logic or code to actually have different versions of caches in your app, just to reflect any changes being done to the code in the app. So we've saved it. Let's go back to the Chrome browser and see if this updated caches can help fix the issue. So back on the Chrome browser, since we have made changes to the service worker, we would have to activate the service worker again. So let's refresh it. Oh, we're offline. So let's get it online and refresh it. So we skip waiting and refresh it again. So you see we still are not able to render the products on the landing page, but you can see that we do have a new cache in place here, static assets 1. That is the new version. So if you go to the app.js that is being cached here you see that we have the products have been uncommented. So we should be able to see the products, but clearly that is not the case here. That is because we have the old cache as well, like static assets, which has the version where the products are commented. So if we quickly go to the service worker again and the fetch handler, so here when it does the caches.match, it will take the first hit from all the available caches. So since we have the static assets here, so it is picking up the version of app.js from that cache. So it's good that we have the logic in place for cache versioning, but there is also a need for cache cleanup because we don't want the older caches still available in the storage when there is a new version of cache available. So we would have to fix that again in service worker in the activate event handler, because this is the event right before the activation of the new version of the service worker. And if at all there is a change in the version, this would be the place to clean up the older caches. So we have the clients.claim here so that the service worker can claim any web pages in the given scope. So we can do self.clients.claim. So that is also another valid way to claim control over the web pages. And in event.waitUntil, we'll do the cleanup. So the event.waitUntil is important because just like we make sure that the event waits here until all the necessary requests to static resources are cached here, we need to make the event handler wait here until all the older caches are cleaned out and only the latest version is fetched in all the web pages. So in here, what we do is we actually get access to cache names that are available. So that is done through the keys method, caches.keys. So the keys would give access to all the available cache names in an array through a promise. So we can use .then method to get access to that array or cache name list. You can name it anything else. So once we have access to the list, what we need to do is we need to check for cache names that don't have the latest version and just remove them. So we'll use the map method to work with each of the entries in the cache name list. So cache name list .map. So we have a method inside the map that gives you access to each entry in the iterable. So cache name, and now we do a check. If cache name are equal to, so we have the cache list here with the names, so we'll use that to check the latest cache names with the appropriate version, are equal to cache list static cache, and it is also not equal to cache list dynamic cache. Then it must be an older cache, so we have to delete it. So we do that with the delete method. So let's quickly go back to the documentation again. Here we have the cache delete method. So it takes the request as an input and it returns a promise that returns true if it finds an entry to delete and false otherwise. So back to VS Code, to caches.delete, and we use the cache name. So return it. Let's console log it as well. Deleting cache, give the name of the cache there. So because the delete method here returns a promise, what map would now have is an iterable of promises. So because we want this to wait until all the caches are deleted, we'll wrap this up in a promise.all method. So what promise.all does is it takes the iterable of promises and returns a single promise only when all the promises returned by different deletes are resolved. So that way you can ensure that the app runs fine, only rendering the latest version of a resource in the latest caches without any remnants from the older caches. So we return it. So that is a part of the code that handles the cache cleanup. So let's go back to the Chrome browser and we're online. So let's refresh it. So again, it's waiting to be activated. Another way to activate a service worker is update on reload. That is the option here. If you just select that and you refresh it, so you see here, it is actually trying to activate the service worker. And now it is active and running. So you see we still have the static assets 1 here and also the older caches. So if you refresh it, for some reason the caches are not getting deleted. So let's go to the Visual Studio Code, see what the problem might be. Okay, I see that we have a typo here. It has to be cache name. So let's see if that fixes the issue. Let's refresh it. Okay, you now see the older caches got deleted here and we only have the latest version of the caches, and you also see that some products are getting rendered here. So that fixed the issue and we're actually able to use the latest version app.js there. So let's refresh it. There seems to be a partial reload. Now we have everything rendered fine. So that's how you can use cache versioning to ensure that only the latest version of different files or resources of the app be used to render content. So if you go to the favorites, that is being rendered fine too. So if we go to the caches and look at the dynamic assets, we see that we have new entries in the cache here, which are like the images of different products, executor camera, shoes, and glasses. So since all of the dynamic content is cached now, we should be able to render them offline like before. So we are offline now, and let's refresh it. You see we have the page just the same like we were online. So I hope this gives you an idea of how we can use static dynamic caching and also cache versioning to manage different versions of files being updated in the app. So our app is starting to take good shape through this offline feature with caching. So that's all for this episode. In the future episodes, we'll look more into caching, like different strategies. So the logic that we implemented for the static and the dynamic caching, that actually falls into one of the different caching strategies that are available. So we'll look at more theory in the next episode on different caching strategies, and also look at caching on demand, where the user might initiate an event or an action that calls for caching some resources. So if you found this video helpful, do consider liking this video, subscribing to the channel, because there is more content coming along in this PWA series. Thanks for watching, and hope to see you in the next one.